Interesting question over here. They've given you two curves. They've told you that they intersect at 2 points. They've asked us to find the x-coordinates of the points of intersection in part A. But then part B asks you to find the area enclosed by the two curves. So I'm going to tackle this over 2 videos. First up, I want to show you how we can diagnose which curve is which. Because whilst they've given you the equations of the two curves, they haven't told you which one is which. So let's have a look at this curve over here. Now, I've mentioned before in a previous video that when your curve touches the x-axis and simply bounces off, that is classified as a double root. And if you look up that video, I've explained that when you have a bracket to the power of 2, that is how you end up with a double root when you solve for your x-intercept. And the only equation that will give you that double root is this one. And so that's why I've labeled this as being y equals to x minus 1 all squared. Now, if you were to look at the other curve, it is clearly y equals to 5 minus x squared because the parent curve would have been y equals to minus x squared since it is a concaving down parabola that is symmetrical or has its turning point about the y-axis. But that parent curve has been shifted up a number of units and therefore it would make sense that it has the equation y equals to 5 minus x squared. So now our question remains, we need to find the x-coordinates of the points of intersection. So let's go ahead, call this equation 1, call that equation 2, and sub 1 into 2 and solve. So 5 minus x squared equals to x minus 1 all squared. Let's go ahead and expand the brackets. You get that. Move everything to the other side. We get 2x squared minus 2x minus 4 equals to 0. Divide everything by 2. We get x squared minus x minus 2 equals to 0. Factorize. And that will give us x equals to 2 and x equals to minus 1. That's how to solve this question.